Hi everyone, this is Kenny Lee, and today I want to talk about center of mass. So center of mass is where all the mass of the object would end up if it's crushed evenly from all sides. So it's the point where we can say all the mass is concentrated. Now, how do we find the center of mass? Well, there's three different ways we can do it. The first one I want to show you is this. Well, it's a meter stick, and it's 100 centimeters long, and it's pretty much uniform thickness. So where do you think the center mass would be? Well, you would think, yeah, it should be in the center, right? Somewhere around 50. So if I balance it, one of the ways you can find the center mass is balancing and slide my fingers in. As long as the center mass is supported, it's balanced. So right at 50 centimeters, or pretty close to it, this is balanced. It will not fall over as long as that center mass is supported. And so even though I'm bouncing around pretty good, it stays pretty much still at that point. So what about the center mass of something like this book? Well, you would think, well, again, it should be in the center, right? Like halfway through here and halfway this through here and halfway through the thickness, and that should be where the center mass is. And again, as long as the center mass is supported, it's balanced. So the center mass actually got out from the support. The book shifted and the center mass got out here past the support, and so it just fell over. So this is not very stable by itself. Any little touch one way or the other could send the center mass past the tipping point. But if we put it down on the table like this, it's very, very stable, because to make it fall over, we have to actually lift the center mass all the way up to here to get that to happen. So if something is stable, its center mass is supported underneath it so that it can stay upright or the way it is. So let's take a guess about this one. Where's the center mass of this disc? Well, again, it should be in the center, because if it's crushed equally from all sides, it should end up right about there in the middle. But this one is one where if we turn it, the center mass stays in the same place. And this is more like neutral, where it stays the same way. Now, I can't fall over this way, but that right there is pretty much stable. What if we get something like a hoop? Where's the center mass of this? Well, again, if we crush it from all sides, it should be right there. You can have the center mass of an object where there's actually no mass. That's still a possibility. And why center mass is important? Well, I've got one of these tools. It's a Weeble. Weebles wobble, but they don't fall down. They always stand up, because if you lean them over, what happens is most of the mass is in the bottom. So when you lean it over, you actually raise the center mass. Center mass wants to be as low as possible and supported, so it's standing straight back up. And you also have ones like this, which is actually a light I got at a hardware store, that does the same thing. But there's another one that we can use, and that's this. One of these bot bags, when you hit them and they straighten back up, because if you can see inside, there is a large mass right there, a big sandbag, so that when it tilts over, it'll want to stand straight back up. And so these bot bags, as they're known, work on center of mass. That down at the bottom, if we lean it over, it actually raises that mass up, and so it will automatically straighten back up for that center mass to be as low as possible. It's the exact same as the way the Weebles work. So we can balance it. Another way that we can find the center mass is by hanging something. So if I've got, actually before we do that, I want to show you this one. This is actually one of the first, not the actual bird, but this type was one of the first physics demonstrations I ever got. And I got it at the end of the day, and I put it on my shoulder and walked around thinking it would spark some conversation about physics. Nobody talked to me. I don't know why. Anyway, as long as the beak is supported, that's where the center mass is kind of concentrated at. And as long as that's supported and it doesn't slide off my finger like it did that time, it's going to stay balanced right there. Same thing with this. Poe. With his arms along the vertical, he's stable. But if we shift his arms up, his center mass goes out beyond his base, beyond his feet, and he falls over. So I can put his arms up like this. He's stable. But if his arms go back, he falls over. So this is another good center mass toy that you can use. Here's another one. Sort of like the tightrope walkers. They have that big pole that they use. And it's weighted at the ends and kind of droops down. So it actually lowers their center mass, makes them much more stable. And so they're much less likely to fall over or fall off that rope. Okay? Because we can tilt it over like this, it'll straighten itself back up each time. All right, so put that over there. It's out of the way. So we can balance it. Another way we can do is hang it. So what about this? Well, it's another disc. And you would think, well, it should be in the center. We crush it in from all sides. But here's the thing about this one. If I was to hang it from this spot up here and draw a line straight down, hang it from this other point, draw a line straight down, they don't cross in the middle. They cross slightly off. The reason why is because I've got a mass right there. So if I try to spin it from the center, I don't know if you can tell, but it kind of bounces. This is why you get your tires balanced, so they won't bounce. But if I put it in right where the center mass is, it spins very smoothly. Well, I've got another one that's like this, except its circle is concentrated or centered around the center mass. So it's the same thing, but now the circles are right around the center mass. And so it spins very smoothly there. You're all going to study a lot of physics. Here we go. We've got another one we can do. This is called a skyhook. And the way you use it is you take a belt, put it in there, okay, and then you put it on your finger. And it looks like it should fall off. But this, draw a line straight down from my finger, and look how much of the belt's on this side of my finger and how much of the belt's on this side of my finger. If you look, that buckle is right in line with my finger where most of the mass is. And so the center mass of this is probably in here someplace. So as long as I'm in line with the center mass, it stays balanced. So we can do the same thing with this. This is just a foam version of the same thing. Let me put it like this so you can see the buckle. But again, it looks like it should really fall off my finger, but again, if you draw a line straight down, you see that about half the mass is on this side, half the mass is on this side. So my support is still in line with the center mass, so it's balanced. Where's most of the mass in something like this hammer? Well, it'd be closer to the metal end, right? And so the center mass wouldn't be in the middle, it'd be kind of more over here. So if I put my finger right about there, it's balanced. But again, as long as I'm in line with that center mass, it's still balanced. Even though this connects here, I'm still in line with the center mass, so it's still balanced. We can try another one. Let's try this. So, we've done two ways to find our center mass. You can balance it and you can hang it. So I've got this bowling pin. If I hang it from right there and draw a line straight down, and hang it from another location and draw a line straight down, I get this. Where those lines cross should be in line with the center mass. So if I connect it here, it should be balanced. And here's the other way. It should be able to rotate smoothly. So we can balance it, we can hang it, and we can rotate it. You'll always rotate around its center of mass. Speaking of which, let's take a look at this one. we've got a wood ball over here, a metal ball on this side. Where do you think the center mass would be? Well, most people get into the trap of saying the center, like right here. But it's not exactly there, because if I put this here and we try to spin it, remember always we'll spin around its center mass. It doesn't spin very well. But if I put it here, it should spin nice and easily, because the center mass is at that location. So again, things will naturally rotate around the center of mass. So that is several demonstrations about the center mass. The important takeaways are this. The center mass is where all the mass of an object will be concentrated. So that's essentially the point where all the mass is focused. You can find it by balancing it, hanging it, and rotating it. And the center of mass has a lot of real applications in real life. Like SUVs, the problem with them is they could roll over because they have a very high center mass, because they sit up very high. So they make the wheelbase wider to give it more stability. Thank you, and tune in for another episode. We'll talk a little bit more about circular motion.